Hi, today Andrew and I are going to talk about COMMO, a cluster-optimized MMO game server. In traditional multiplayer game design, the server is the bottleneck and the single point of failure, because the server is a limiting factor in the number of clients that can connect and has to manage all the game state for all of the clients. COMMO is a semi-decentralized game protocol, where clients also have to act as servers, but the master server is still used as a service discovery. One of the key properties that we want to exploit in COMMO is proximity. Specifically, clients are probably more likely to care about messages from clients that are close by within the game space. This is to reduce the communication bottleneck, and this is a pretty realistic assumption because in most games, you can only interact with players that are within some range or relatively close by to you. So in COMMO, the clusters that we form are more like shards, where the game is also sharded based on location, and clients that are close by join each other in the same shard. Because this is still a decentralized protocol, there are still some concerns around reliability. So specifically, if one of the clients leaves, we don't want the whole game to grind to a halt. So our very simple game implementation involves a character that can move around in a 2D board and can also attack and heal those other clients that are within some proximity range, which is the green circle illustrated here. This is what it actually looks like in the demo that Andrew will show in a few minutes. So the key idea behind our decentralized design is at the game start, we divide up the board into shards, and each client is assigned to be initially in one of the shards. As they move around, they can dynamically switch which shard they belong to, but each client also holds a dual responsibility, as in it is potentially itself a shard server and it has to manage concurrency and consistency between all the actions that happen within that shard. However, because we use a Raft consensus protocol, we make sure that no one client is ever the single failure point for a shard. This is our diagram of roughly how COMMO works. In this diagram, there are three different types of roles that a client can assume. They can either be a normal client with an additional responsibility of being a shard manager, so that means they're part of the Raft cluster responsible for some shard, not necessarily the same shard that they're currently in. The Raft cluster can also elect a shard leader. This leader is responsible for actually talking back to the master server from time to time to do some kind of health status. And you can also be a normal client with no sharding responsibilities. Usually if, for example, a client is too slow, we might not want to assign any additional networking responsibilities to that client. And the master server now acts simply as a service discovery for all the clients that want to join the game. So now we're going to walk through the COMMO API protocol really briefly. So to begin with, all the clients first try to connect to the master server via the join game interface. This assigns them some kind of unique ID. Secondly, they get any kind of shard assignments. So the server might pick some of the shards to be, some of the clients to be responsible for certain shards, and some of the clients to not have to do any additional shard networking. Among the shard group, the Raft protocol then chooses one leader. The leader reports back to the master server that it has been chosen as the leader of a particular shard. Once the master server hears back from all the leaders, we can start the game. And keep in mind that as soon as every single client has called start game, they have a shard directory available to them, which they can then store locally. So that means if they ever switch shards or join a new shard, they know which hosts they can contact. So next, a client is assigned a shard based on its physical location in the game world. It asks to join that shard. It can talk to any of the clients that are acting as the shard servers. once the game starts, each client can start taking actions within the game space. Again, this can be move, attack, heal. Via Raft, we replicate those actions and achieve consensus within the shard. If one of the nodes within the shard leaves, for example, some client just decides to quit the game, Raft can elect a new leader and notify the master server that it has now taken the leader responsibility. Finally, if the master server itself goes down, technically the game can continue. It won't be able to support any new clients joining. And if there are failures within the shards, it won't be able to update the global directory. But the game can continue in the current state. And within the normal course of the game, as the client moves around the game board, it can join different shards based on where its location is. And in that case, it would notify the current shard that it's leaving and ask to join one of the shard clients within the new shard that it wants to join. Cool. And with this, we're going to turn it over to Andrew, who will run through a quick demo of how this works.